Hi guys, in this video we will be looking at Tan-chord theorem. It states that the angle between a tangent to a circle and a chord drawn from the point of contact is equals to the angle in the alternate segment. Well, if you are new to this channel, what are you waiting for? Kindly subscribe. You only subscribe once. Like and comment. Right. Well, guys, we're still looking at Euclidean geometry grade 11. Yes, now we are looking at the tangent. If you look from our playlist, you could see that we have number of videos of Euclidean geometry, from center theorems to cyclic quads, right, with activities. But today we'll look at the proof. The activities will follow as well. So let's dive in this video, right? I won't be too hasty or in a rush because I don't want to crash, guys. I always say this: don't rush because you'll crash. But that doesn't mean that you should be slow, but it means that you should be moderate, because so that you can do things proper, right, guys? We don't want to crash. So without wasting time, let's get to today's video. Well, we have stated that the angle between a tangent to a circle and a chord drawn from the point of contact is equals to the angle in the alternate segment. That's what we are told. That's what the theorem Tan-chord states for. So what is nice is that we are given that PCQ is a tangent, and CB, we're being told that PCQ is a tangent, and we're being told that CB is a chord, right? And A is a point on the major arc. We're being told that A it's a point on the major arc. So this is the major arc. So first thing, guys, you can't prove a theorem without a construction. So you will need to construct first. So construction is very essential in this proof. So what I will do, guys, remember that we are proving RTP stands for required to prove. RTP, given as RTP there, required to prove that BCQ is equals to BAC. That's what, where is BC? BCQ is equals to BAC, right? We will prove that. So without wasting time, let's start with the construction, guys. You must have a construction first. So I'll write construction. For you to build any building, you must have a construction, guys. So you will do well if you construct first. Yes, construction. So for us to prove this, we need to draw a diameter. So we are going to draw diameter CD. So if I construct this, I have to be, I'll use a dotted line. Use dotted line. I'm constructing a diameter. Remember, a diameter, guys, cuts the circle into two equal paths. Then you draw diameter. Then let's name this CD. So in other words, you are going to draw CD, draw diameter, right? Diameter CD, and we will also join here, join AD. We will also join AD. So join AD. AD here becomes is a chord. So when you look at this, it's now more of a cyclic quad. Do you agree with me? Let's see why I'm saying so. It's 1, 2, 3, 4. It's quanticyclic. It touches 4 times here, guys. So that's why I say it's more of a cyclic quad. It's more of a cyclic quad. And guys, I want you to note this in your notebook. This theorem that we are proving, it's examinable, so they can ask you in an exam to prove it. It usually goes with 5 to 7 marks. So depending on the examiner, whether he or she will give it 5 marks or 7 marks. But this one, guys, I want you to put that in your mind that it is always examinable. It's always examinable. It's always examinable. It's either they can take it out on prelim or final, but just know that this theorem is examinable. Yes, that's what I want you to take note of. Right, we are done with our construction. We've construct, we have shown draw diameter CD and join AD. We have seen that this is a cyclic a quad. Now it's a cyclic quad. Then from there you are going to write proof, because we are proving here. Proof. So now it's time to analyze what we are given, guys, so that we do things in a proper manner. So I will name this A1 and name this A2. Also name C1. Also name this C2. Guys, can you see that at C1 and C2 we have a tangent which is perpendicular to the radius? There's a radius there. Can you see the radius? From the circumference to the center. We also have a tangent. So this will form sort of 90 degrees here. In other words, it will form 90 degrees. So in other words, angle C1 plus angle C2 is equals to 90 degrees. So it is because we have a radius which is perpendicular to the tangent, or tangent perpendicular to the radius. I hope you're getting it. Remember, this is a statement and it must be accompanied by the reason. So the reason will be tangent, tan perpendicular to radius. So tan perpendicular to radius. So it's our tangent, which is perpendicular to radius. So in other words, we now have a mark for drawing construction. Then we have maybe 2-3 marks now. If then we will be left with 4 marks. It's just, I don't know whether your examiner will want, where will he start to mark or she will start to mark. So it's very essential that you know that a statement must be accompanied by, or must be associated with a reason. You must support it. You must substantiate by using a reason. So your statement must go with a reason. We are not done, guys. We also have to analyze another thing. Can you see that here A1 and A2 forms a 90 degrees? Do you know what is the reason? It is because of a diameter. A diameter subtends a right triangle, a right angle. A diameter subtends a right angle. It creates 90 degrees. In other words, subtends means to create. So it creates 90 degrees. So in other words, it means that angle A1 plus angle A2, guys, will be equal to 90 degrees. I hope, guys, you're looking at this. Very important. A1 and A2 is equals to 90 degrees. Then you may ask, Mr. Richard, what would be the reason? Remember, when a diameter subtends a right triangle, the reason will always be angle in a semicircle. Now, remember, it's no longer a full circle because diameter divides this into 2 equal parts. So in other words, you are going to say angle in angle in semicircle. So this will be the reason. Angle in a semicircle, angle in a, so we can just put a, angle in a semicircle, right? This is the reason. Remember, your statement must be accompanied by your reason, right? So we are not done. Now we can note that both of these, angle C1 plus angle C2 is equals to angle A1 plus angle A2, right? Therefore, I want you to see another thing again here. Can you see that this forms a bow tie? It forms what we call angle in the same segment. Can you see that angle A1 and C1 are angles on the same segment, right? So they form, remember this is more of a bow tie. So it's a cyclic quad. Angle A1 and angle C1 are equal to each other. So therefore we will say angle A1 is equals to angle C1. It goes with the reason. That will be angles in the same segment. Angles in the same segment. Sorry for that. It's angle A1. Angle A1. Yeah, now the big question is what to do next, right, guys? The big question is what to do next. So what to do next is to say that, can you see that angle A2, we are now proving angle BCQ is equals to BAC. Therefore, we could say, let me just say, therefore, angle A2 is equals to angle C2. Therefore, this means that angle BCQ is equals to angle BAC. So they are equal. We have proven this theorem, guys. We have proven this theorem. So whenever you use this theorem, I want you to take note of this. Whenever you use this theorem, your reason will always be angle between a tangent and a chord, or you could say tan-chord theorem, guys. Yes, you could say tan-chord theorem. That's the valid reason, guys. That's the valid reason. That's how you can reason your theorem or your rider when you see something like that in a rider. In other words, this, you will always look at this angle, which is it's an angle between a tangent and a chord. Is equals to this alternate angle. Is equals to the alternate segment. So in other words, this C2 is equals to A2. So always look for this, then you'll be fine. So see you on the activity that involves Tan-chord theorem. If you're new to this channel, what are you waiting for? Like the video, comment, guys. Let's grow the community. And remember, we love you.